uncle. My name is Shravan and he is Setupati, and our guide teacher is Ken Victor sir, and we are coming from Narayana Olympiad School at Nellore, and our project is on magnetic linear accelerator. Here we are using only some force and creating more amount of effort. Or we are producing an acceleration in the final body. I am not producing any force, not providing any force, but the final velocity increasing. This is because due to the attraction of this magnet, some kinetic energy is produced, and it is transferred to this bearing, and due to this position, some potential energy is produced.
Do you take it?
Take it. We call it linear because it is in a line. Keep it.
Leave it. Table is not in proper.
Yes, sir. Yes, sir. That's what the main.
So I ask them to lift the table. Little. Put some paper and all. Make it level. That table must be leveled. Wow. Big hands.
This is due to the attraction of a magnet, some kinetic energy is produced, and it is passing through the final magnet, and due to its position, potential energy is produced. And due to the attraction of a magnet, again potential energy is lost and kinetic energy is produced, and so on. And due to the loss of potential energy, kinetic energy is increased. Now my friend will continue.
So when we consider the atomic transitions, an electron will jump from low energy state to higher energy state whenever we provide some amount of energy which is equal to the difference in between the two energy states. For example, when the electron jumps to the higher energy state, it stays there for about 10 to the power of -8 seconds and then radiates the energy in the form of electromagnetic radiation and comes back to lower energy level. This is a purely hypothetical, imaginary concept, but this is the visualization for this model. This is the practical evidence as well as visualization for this model. Now, how can we explain this atomic transitions with the help of this model? We can have a look. If at all we consider this as a ground state and this as excited state, so all the excited state again loses the energy and all the lost energy is converted in the form of kinetic energy, whereas here during the de-excitation of electrons, the energy is lost in the form of electromagnetic radiation. This is a major difference. And here we can see this is a cyclotron, in which we use these electromagnets in order to accelerate these particles. For example, when ion sources are sent with the least amount of energy, these two electromagnets they make the ion get accelerated, and while coming out they come with about 150 million electron volts of energy. This is a major application of this process, like magnetic accelerator. And here this is one of the experiments by which we are all we all wonder. Actually, this is an experiment that the scientists are conducting in Switzerland. They are doing it to understand the formation of the universe and how the universe was formed, and they are doing it to know about the black matter which we do not know. So if at all they get succeeded in this experiment, we'll know about what is the universe, and we'll know every property of the dark matter. So in this we are using the same principle, and about thousands and thousands of magnets, strong magnets we use to focus the beam and accelerate the beam. Here what actually happens is that two beams of particles collide each other, and with the resulting matter and the resulting waves we are in a position to analyze them and judge the formation of the universe and the dark matter. So this is the major applications of accelerators. It can be used in nuclear physics. Whenever in nuclear physics we have to bombard uranium-235 with some high energy proton or neutron, we use these kind of accelerators to accelerate the proton or neutron. And even in radio biology, this is a graphical representation of this experiment. Like this graph shows initial velocity and change in kinetic energy. So as the initial velocity increases, the change in kinetic energy decreases. So So that's we can understand by this graph, and this shows the accumulated varying displacement in inches and change in potential energy of the same experiment. Whereas this graph shows displacement in inches and force. The displacement force curve is maximum when it's at the contact point. So maximum transfer of force takes place. So in the major uses in treatment of tumors and cancers, if at all we aggregate some kind of ions with the high velocities, we'll get some kind of radiation. If at all electrons are getting transited from the inner orbits, we'll get the production of X-rays. So similarly, you can use those rays to treat cancer and some other tumors, as well as for scanning of cargoes. We need some powerful rays which can pass to any matter. So those kind of rays we can produce through these kind of accelerators by accelerating the suitable ions.
Again, as we come to the conclusion, we are using a principle called principle of conservation of energy in this experiment. That's it.